Welcome to today's exam riddle. Here we have a reaction scheme for the synthesis of dihydroaflatoxin, this compound. We have two starting materials, and here the reaction conditions: sodium ethanolate in ethanol, heating it up, and the result is then already this five-membered ring system. The task now is to develop a reasonable mechanism for this reaction. Please try to solve this problem first by yourself and then listen to the offered solution. So, how should we approach this type of reaction? Well, we just have a look where we can find these structures of the starting materials within the structure of the product. And well, here we see that aromatic ring with a methoxy group. We find it here in the center. Well, that means, and the five-membered ring is annihilated here. That means this is one of the bonds that had been formed, and the other one is between this oxygen and that carbonyl group. So, here on the left-hand side, we have the part that derives from this starting material, and that five-membered ring plus that carbonyl group derives from this one. So, two bonds have been formed by certainly polar reactions. And let's have a look. Well, one bond has been formed from this oxygen to that carbon. This oxygen here certainly has donator reactivity. Natural reactivity of a carbonyl group is acceptor reactivity. Then we find the CC bond formation between this and that position. Here it is an electron-rich aromatic system that also has donator reactivity. And here, beta to two carbonyls, alpha-beta unsaturated compound, we have an acceptor reactivity also at this position. So what is the role of sodium ethanolate? Well, it additionally activates the nucleophilicity of that ring simply by deprotonating here. So it is deprotonated. The acidic phenol is deprotonated. Then we have a phenoxide, more electron density overall, more nucleophilicity. So let's have a look. This is deprotonated. The nucleophilicity of this position will even rise further, and then it attacks this one as a conjugated addition reaction in the first step. Let us draw this. So, CC bond formation. Between this position and that, the bromide is still sitting here. Conjugate addition process means an enolate is formed. Here we have the ester functionality. There was the oxygen, or is still the oxygen. A double bond is formed here. And here, this hydrogen is still present. So this is the reactive intermediate after the CC bond formation between here and there by a conjugate addition process. Addition, then elimination, and also a tautomerization. The formerly aromatic system is not aromatic in this reactive intermediate, but as soon as we make a tautomerization to the enol, then we have re-established that aromatic system. So, let's draw the next intermediate. As I said, tautomerization here. Bromide is eliminated. And don't forget the methoxy group here. This is the next intermediate. So we have still sodium ethanolate present. Again, now the phenol is deprotonated, and now this phenolate then intramolecularly will attack the carbonyl group, addition, elimination process, lactone formation, and simply ethanol is eliminated and we have reached the stage of the dihydroaflatoxin. Thanks for listening.